Hello kids, today we are going to graph absolute value functions, and that is going to be our goal for the day. So we are going to be given an absolute value function and we are going to plot some points and see what its graph looks like. In order to graph absolute value functions, we'll have to know what the general form of an absolute value function looks like. And that is f of x is equal to the absolute value of x minus h plus k. So we actually have some new letters in there we're not used to seeing. We have an h and a k, and actually those h and k's represent a certain aspect of an absolute value function, and that would be its vertex. So the vertex of an absolute value function are the values h in place of x and k in place of y. Now notice that in the absolute value function general form, it's a minus h inside the absolute value bars, but outside in the actual vertex, it's a positive h. So when you're pulling the vertex from the general form, make sure that you flip the sign and that you use the opposite sign for the actual vertex. Notice that on the k is a plus k, and in the vertex form it is also a positive k. So that sign actually does not change at all. So let's start with a graph. We are going to graph the absolute value function and then identify its domain and range. Our first example is the parent function f of x equals the absolute value of x. Now this one doesn't look much like our general form because there's nothing being added or subtracted inside the absolute value bars, or there isn't anything being added and subtracted on the outside. But actually, there is something being added inside and outside, and those would be zeros. So the absolute value of x plus 0 on the inside plus 0 on the outside is the same thing as just the absolute value of x. Written this way, in the same way as our general form, it's now easier to identify what the vertex is. So remember, the vertex is the value that's in the opposite of the value that's inside here, so that would just be 0 for the x, the h coordinate, and then the value that is on the outside, so that would also be 0 for the y coordinate. So now that we have our vertex, we're going to move right into making a table so that we can plot some points. So just like our piecewise function, we'll have a table consisting of an x and an f of x column. Now in our x and f of x column, the first thing we're going to put in is the vertex. And notice that I put the vertex a little bit down in the table. My goal is to put it in the middle of the table, because what we're going to do is, since absolute value functions are symmetric, we want the same amount of points to the left and to the right of our x coordinate. So after you put your vertex in the middle, then we're going to pick 2 points to the right immediate left of the first of the x coordinate of the vertex. So going to the left from 0 we have -1 and -2, and going to the right from 0 we have +1 and +2. So depending on what your vertex is, you pick the 2 points to its immediate left and 2 points to its immediate right. Now, in order to figure out what f of x is, or y, we are going to plug in our x coordinates. So we're going to take all of these values and plug them into our original function over here. So I'm going to erase that just to give myself some more room, and I'm going to start plugging in. So the first value I'm substituting is -1. So I'm taking this value right here, I'm substituting -1 in for x into my original function. So f of -1 is equal to the absolute value of -1. F of -1 is, now we evaluate the absolute value of -1, which is +1. So that means that for f of -1, my value that goes in for f of x is +1. Now let's evaluate f of -2. So now we're going to plug -2 into the original function. F of -2 is equal to the absolute value of -2, and the absolute value of -2 is +2. So +2 is my value that goes in for f of x. So now I have 2 points. Let's figure out what the other 2 points are. Next, I'm going to move down the table and work with f of 1. F of +1 is the absolute value of 1, which turns out to be 1 because just because it's positive, it stays positive because remember absolute value is the distance from 0. So f of positive 1 is positive 1. And we have one more, and that would be f of positive 2. F of positive 2 is equal to the absolute value of 2. Absolute value of 2 is positive 2. So f of positive 2 is equal to positive 2. So now that we have a pretty solid table of values here, now we can go ahead and graph them. So I'm going to first graph negative 2, 2, negative 1, up 1, 0, 0, over 1, up 1, and positive 2, 2. So I have all of these points, and you can see actually the shape that they make is a V shape. In this V shape, you can see that the points actually are reflected off one another down the vertex because we have created a line of symmetry. So through the vertex of your absolute value function, there is a line of symmetry, which means that any points on the left side of the vertex will reflect to be on the right side of the vertex as well. So this point, negative 1, positive 1, its y-coordinate reflected to be positive 1, and same with this y-coordinate of 2 reflected to positive 2 on the other side. So that'll save us some time in the future. Now that we have our absolute value function, we are going to state its domain and range. So for the domain, just to show you that those are the same and that they do reflect. For our domain is what does the graph cover as far as our x values go from left to right. So as you can see, our graph is going up and to the left. So it's going to keep going to the left for infinity to the left, and it's also going to keep going to the right towards positive infinity. So that means that and since it does not break at all in the middle here, our domain is from negative infinity to positive infinity. Now let's do our range. The range is what's happening with our graph going from the bottom to the top. What y values does our graph cover? So from the bottom here, our graph doesn't actually start until this y value right here. So at that y value, that's where our graph starts, and then it keeps on increasing in both directions from there. So what y value is that? Well, that y value is 0, keeps on increasing, and goes to positive infinity. Let's try one more example. So in the second example, we have f of x is equal to the absolute value of x plus 1 minus 4. So our very first step is to always find the vertex. So our vertex, remember the x-coordinate, or the h, is opposite sign of what's inside the absolute value. So inside the absolute value we have a positive 1, so our vertex x-coordinate will be, O for opposite, negative 1. Our y-coordinate of the vertex will be the same as the number that is on the outside. So our y-coordinate of our vertex will be positive 4, S for same. Now that we have our vertex, we can insert that into a table of values for f and f of x. And remember that we want to stick that vertex in the middle of the table of values, and then from there list 2 points, 2 x-coordinates directly to the left and 2 directly to the right. So our x-coordinate to the left of negative 1 would be negative 2 and negative 3. On the opposite side of negative 1, we would have 0 and positive 1. Let's start plugging in some values into f of x into x to determine what our f of x is. So I'm going to start by plugging in negative 2. F of negative 2 is equal to the absolute value of, just plugging in negative 2 in here for x, negative 2 plus 1 minus 4. Remember, that gets plugged into the original function. Now we just evaluate. F of negative 2 is equal to the absolute value of negative 2 plus 1, which is negative 1 minus 4. In our next step, we evaluate the absolute value of negative 1 to get positive 1. And finally, 1 minus 4 gives us a value of negative 3. So in this function, now we have what is our f of x. For x is negative 2. We have negative 3. Now we're going to do our negative 3 x-coordinate, plug that into the original. So f of negative 3 is equal to negative 3 plus 1 minus 4. f of negative 3 is equal to absolute value of negative 2 minus 4. And we evaluate the absolute value of negative 2, which is positive 2. Finally, subtract 2 minus 4, and we have negative 2. So our f of x value for x is equal to negative 3 is negative 2. Now remember what we said about the last problem, that since absolute value functions are symmetrical, that we can just plot these points first of all, and then duplicate across our line of symmetry. So now we know that our corresponding f of x value for x is 0 is negative 3, just like the corresponding value of negative 2. And just like above, our corresponding value of negative 3 is negative 2, so our f of x for positive 1 is also negative 2. So we'll graph those points as well, fill in our other side of the absolute value function, and we have made our absolute value v-shaped function. Now let's figure out our domain and range. So again, our domain is what is our graph covering from left to right, and since our graph keeps moving to the left on the left side of the V, to the right on the right side of the V, our domain is from negative infinity to positive infinity. And our range is what is our graph covering from bottom to top. Our graph doesn't start until around this value here, so that y value going upward is 4. So that means our range is from 4 to positive infinity. Those are absolute value functions. Please write down any questions that you have and try the examples on the back of the page. See you tomorrow.